Okay, we'll get started. Yes. I'll tell you. So the final exam, you'll see where I'm clicking. It says tentative here, but the tentative date is the correct date. And so it's April 25th, which is a Friday, I believe, from 7 o'clock to 10 o'clock. So they'll try and match it to the same time as class, but yeah. Okay. Okay, there's one logistical thing I want to mention. I'll mention it at the end of class too, because there'll probably be more people here. I'll be traveling 2 weeks from now, and meaning that the next lecture is on social engineering. Most semesters I end up traveling one class, and so I have a pre-recorded lecture for social engineering. Even though it spans two lectures, I just recorded it as one chunk. Okay, so it's a little longer than one class, but it's a little less than two classes. So what we'll do is, since I have it recorded anyways, and you'll start watching it next week, there'll be no in-person class. Actually, this will be the last in-person class. So next week, you can watch the online lecture. The week after is the week I will be traveling. You can finish watching the last lecture. And what I'll do is I'll have a Zoom call. Because I have to speak at a conference, it's at the end of the day. We won't start right at 5:45. We'll maybe start at 7 or something like that. And then if you have any questions I'm sure you'll have questions about the exam and things like that, and also about the social engineering, then you can ask your questions then. Okay? If you have questions now too, I can answer those as well. But yeah.
So you have mentioned that the project submission is the last class.
Yeah. So last class in this case means like the virtual class or whatever. Yeah. So it would be 2 weeks from today. Yeah. Does that work for everyone?
It would be better if you extend 1 week.
So I can do that if you want. So yeah. So 1 week would be. Let's see. I think it's a holiday, right? Is it Good Friday? Yeah. Yeah. Okay. So I'll give you an extension till the Friday, but since it's a holiday and then Monday's Easter Monday, I'll extend it to the Tuesday after. Okay. So it will be due without penalty. Yeah. Okay. Let me. I'm just going to change it now because otherwise I'll forget what I said. I'll have to go back and watch the video to figure out what I said. This is a really annoying bug with Moodle. Do you guys get that bad header thing or no? Okay. I get it all the time, so maybe it's something with my configuration. We could diagnose what the problem is, but. Okay, it's not going to let me edit it for reasons I don't understand. I'll just make a note to myself. Remind me in 2 hours to update the project deadline. Yeah, I don't have Chrome, but I have Brave, which is Chrome, and it will work. Okay. Okay, other questions? Yeah. Yeah. Yeah, that's right. Yeah, so next class there won't be anything. Either if you want like a question and answer, we could do it, but I figure like you might as well have a break. So yeah, so next class there won't be anything, but do watch the YouTube videos. Okay, try and watch them so that you're ready for the week after, and then the week after we'll do the Zoom. I'll put the link on the Moodle, and and I'll take your questions about the course, the exam, whatever, and then also about the social engineering lectures themselves.
So it will be like office hours or like
It will be-
replacement?
It will be a Zoom where I bring all of you in at the same time. Yeah, so it will be like just open to whoever joins. I'll record it. I'll put it on Moodle after as well. So if you can't make it, then you'll get a recording of it. And then, it'll just be an open mic. And if no one has questions, then it'll be over in 5 minutes. And if you have questions, then I'll stick around as long as you have questions. Yeah?
You wanna post the link by in Moodle or?
Yeah, I'll put it on Moodle, and I'll send an email too, just because there's a lot of people that aren't here and they might not watch the video from today until next week. They might show up or something like that. So I'll circulate an email just reminding you. Probably I'll send one before next class and then one before the call as well. But yeah, so absent everything else, the link will be on Moodle itself.
So 2 days physically last class.
So today will be the last in-person class. Yes. Yeah. So if there's anything else you want to ask me while you have me in person, you can. But I don't know that there is particularly. Just the exam I think I talked about at the start of class, but it will be it's scheduled for 3 hours. It's not going to be a super long exam. It will consist of short answer and multiple choice. And bring a pencil. So the Scantron, the multiple choice you'll do on Scantron, so you need a pencil. It won't accept pen. You can write the short answer in pencil as well. It's not a problem. I advise you to anyways, because then you can erase if you need to. You can bring a cheat sheet, so one piece of paper. You can write anything you want on it, front and back. It can be written, it can be typed. You can bring a magnifying glass, it doesn't matter. If English isn't your first language, you can bring a dictionary. If you want a calculator, you won't need it, but you're free to bring one anyways. Yeah, that's about it. There is a practice exam on Moodle, but it's very old, and half of the stuff on it we don't talk about anymore. I would actually just not put up a sample exam, but students begged and begged and begged, so I put up an old exam. I don't think there's solutions to it. I don't remember. If you go digging on YouTube, you can maybe find the year that exam was given and find the YouTube video that goes along with it. But yeah, it's just there, and I honestly wouldn't even bother with it, or maybe just skim it just to get a sense. But I don't think it will be that useful. But we'll see. I haven't written the exam yet.
So it's a pattern, like you give the same pattern in the exam?
No. So that one also was a different pattern. Yeah. So it was just all short answer. So this year will be mostly multiple choice. You can expect like. Can't remember what I did last year. Maybe or last term. I think it might be like 40 multiple choice, something like that, and then a couple short answer. Yeah. So you should have lots of time. You should have time to sit and think about the questions. It won't be the kind of exam where you're rushing through and barely finishing. Usually students leave after the first 45 minutes, and then some students stay to the end as well. But the majority of students leave, like they don't. At the very end of the exam, when the time goes, there's maybe 3 students in each room or something like that. So I don't think time is an issue. Yeah.
What was their class average last semester?
I don't remember off the top of my head, but it tends to be pretty low. And then so we do curve marks. So your rank is more important than your class out, like the actual grade on the exam. But yeah, it was very low, let's say. But it's okay. I mean, as long as everyone's in the same boat, it doesn't matter. It will be like it'll be a tricky exam. I do want to. I mean, the main motivation is to separate the really good students who understand everything from the students that sort of understand stuff to the students that don't understand stuff. And so you have to ask tricky questions in order to do that separation cleanly. But yeah, no one failed last term, the course. And your project's a big component, your assignments are a big component of your grade as well. And so don't feel intimidated by the exam just because I said the average was low. That just meant everyone in the class was in the same boat, so yeah. Other questions about it? Okay, good. So in 2 weeks, you can ask me other questions if you think of them between now and then. Okay, we'll jump into the lecture then if there's no other questions. Okay, so last class we talked about the cookie policy. So this is something that's implemented by browsers, and it's meant to basically decide when you send a cookie back, particularly when you're on websites that weave together content from lots of different sources or origins. Today we're going to talk about something very similar, which is, let's say you have JavaScript, it comes down in the website that you're visiting, and maybe you're on website A, but website B is feeding JavaScript into the website or website C. Then what happens? In particular, JavaScript is pretty powerful. It can see like the content of the website, and so are we going to try to isolate them, or are we going to try and run them all together, sort of in the same context? Okay, and the answer is both. So you can do it either way, but we have to understand what the policy is to understand what you're getting depending on how you set it up. Okay, so again, just to show this from last class and also way back from SSL, you have the content of the website that comes down. You have the stuff that's in the headers. Cookies, which we talked about last class, are in the headers. Okay, today we're going to be talking about the content itself. For passive content, we don't really care that much about it. So passive content, as you know, like even if it doesn't even come over HTTPS, the browser probably is not going to complain about it anyways and let it go. But for active content, in particular JavaScript is the most famous of it, we care a lot about it. If you get bad JavaScript running on the website that you're looking at, it can basically like completely change everything that you're looking at. Okay, so trying to keep bad JavaScript off is important. So we saw that in HTTPS. If you download JavaScript over HTTP, a man in the middle can replace that JavaScript with whatever they want. And so that's a big threat. Okay, so we don't allow that to even happen. And now we're going to talk about what happens when you start weaving, like in particular, let's say you have ads, you want to put ads on your library, you're going to give JavaScript power to some ad provider. And so now they're running JavaScript on your library. Or sorry, on your website. Okay, so what the browser does, the basic policy it implements is called the same origin policy. Okay, it's something you may have heard of or maybe not. And it governs how resources on a website are isolated or not isolated from each other. And so what happens is that when you go to a website, you load a whole bunch of resources. I'll just demonstrate this. So you can see when I load TSN here, these are what we mean by resources. So there's a bunch of images that come down, JPEGs. I guess it's kind of small to see, but you can see there's tons and tons of resources on this website. And you can see that they come from different domains. Okay, so some of them come from TSN themselves, but some of them come from other places. All right, it's all getting kind of weaved together on this one website that I'm looking at. Okay, some of these resources will be active. So actually, I had a filter on. I'm not sure why, but we were actually before just looking at images. So now we're looking at everything. And if you want to see like just JavaScript, you can see that there's lots of JavaScript on this website, and it comes from lots of different places. So Google's putting JavaScript here. The Zotero thing is an extension that I have installed. That's not from the website itself. There's Bing, there's more Google, scorecard research, DoubleClick, Optimize, blah, 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 blah. Okay, so you can see lots and lots of JavaScript being weaved together on this particular website. Okay, so what the browser is going to do is it's going to ask where did this it's just going to ask where this resource came from, including every resource, images, HTML, and things like that. And it's going to tag it with an origin, okay? And then it's going to do something about that, which we'll see later. Now, the origin is not necessarily the same as where it got it from, okay? So we'll go through these details in a second. But anyways, that's its job. It's going to tag everything. It's going to say, okay, I'm giving this JavaScript origin TSN. I'm giving this JavaScript origin Google. I'm giving this JavaScript origin DoubleClick, okay? Then what it does is it puts all the resources in a data structure, which happens to be a tree called the DOM tree. And one thing that JavaScript can do is it can walk around this tree. So it can say, show me what else is in the tree. And then the browser will respond. And it can even overwrite the tree. So it can say, okay, I see this image, it's in the tree, I want to change it. So change it to this or whatever. Okay, so JavaScript can walk around the tree and it can change things and it can read what's in the tree and things like that. Okay, so in other words, it can see and change all the other resources that are on the website. All right, so and not just JavaScript, there's other forms of active content, but JavaScript's the most predominant now. Most of the other ones we don't use anymore, things like ActiveX or Flash. A lot of these things have gone away because JavaScript is now simple and it's powerful. Okay, so the basic story here is, let's say you get a bad script running, then it can change, because it can rewrite the whole tree, it can basically change the entire website that you're looking at. Okay, now the one thing I want to emphasize is, if you get a bad script and it changes the website, it's changing it in your browser looking at the website. It's not changing what's on the server. So the server is still trying to send you the right website. And if you stopped having this bad JavaScript, you would all of a sudden get the right website. Okay? So it is changing the website, but it's not like it's hacking the server or something like that. Okay? So it's just changing how you look at the website in your browser. So that's one limitation to it that's important. Okay, so we said resources are tagged with the origin that they were received from. So what is an origin? So in this case, an origin is going to be the domain that it came from. It's going to be the protocol that it was received over, and it's going to be the port number that it came over as well. Not that we use ports anyways. And then there's going to be this override flag that we'll talk about later. Okay, so an example of an origin would be test.popspy.com. It came over HTTP as opposed to HTTPS. It came over port 80, which is what HTTP traffic always comes over. And this is the flag that we'll just not worry about for now. Okay. Now, if let's say there's something that doesn't match exactly all four elements, then it's not considered to be the same origin. Okay. So I thought I had an example, but I think there's a bunch of slides with examples, but let's say that it came over HTTPS instead. Okay, then that's a different origin than HTTP. Okay, or if it came from pulpspy.com as opposed to test.pulpspy.com, then that's going to be a different origin. Okay, so things are the same origin only if they match in all regards. Okay, so exact same domain and exact same protocol that you receive it over, exact same port, which is usually goes hand in hand. Like HTTPS will come over 443 and HTTP will come over 80. But your browser is powerful enough that you don't tend to use it, but it can run other protocols as well. Like you could type in FTP:// or mail2://. So there are other protocols that you probably don't use very often, but they are there. Now, let's say that you want to have a resource that's loaded and you're coming from, say, test.pulpspy.com, but you don't want the browser to assign that origin to it. You want it to assign a different origin to it. Are you allowed to do that? And so the answer is yes, to some extent. So one thing you can do is you can move up the domains. So if have test.pulpspy.com, I can say, give me origin pulpspy.com instead. Okay, so I moved up, but you can't go all the way up to .com. This is very similar to cookies. Okay, so same thing with cookies. You can specify what the domain is when it should send it back. You can move up and down domains, subdomains, but you can't go all the way up to .com. How do you do it? So in JavaScript, you would say something like set document.domain equal to pulpspy.com. The browser would look at it and say, okay, are you allowed to do that? Yes or no? And the answer is yes, if you are pulpspy.com or if you're some subdomain of pulpspy.com. Okay. What you can't do is, let's say you're facebook.com and you're sending stuff and you're saying set domain to pulpspy.com, then the browser won't let you do that. When you run this command, it flips that override flag to true. So it means yes, you overrid your domain.
I'm sorry.
Yeah.
Here, I don't understand that. Okay, we are moving up, so removing that supplement. Right?
Yeah.
But our purpose is, so after we manipulate the JavaScript in the browser,
Yeah.
also we want to manipulate the URL, keep the same content, changing the URL.
Yeah, okay. So this lecture is a little out of order. Let me first tell you what the same origin policy is, even though it will come, okay? The same origin policy is that basically think of a website. I said there's these trees, or there's a tree. In reality, there's trees, okay? And every origin has its own tree. And if you are not you can only access the tree for the same origin as you. Yeah? Okay, so facebook.com will be its own tree, and pulpspy.com will be in its own tree, and Facebook can't overwrite pulpspy stuff and vice versa. So that's how the browser is going to isolate it. Okay, so there's two places where the domain shows up. The first is like, who's giving me, whether it's JavaScript or an image or something like that, like who's it actually coming from? So let's say it's coming from test.pulpspy.com. Okay, that's who's giving it to me. We're not doing anything in terms of like rewriting, changing how it looks for the user or anything like that. Okay, it came from test.pulpspy.com. What we're changing is we're saying, don't put me in the tree for test.pulpspy.com, put me in the tree for pulpspy.com instead. That's probably a better explanation, right? Yeah, okay. So that's what we're doing here. So when we override the domain, we're just saying, put me in a different tree than the tree that you were going to put me in. Does that make sense? Okay. So then what would happen is it would go in the tree pulpspy.com, search over this, and now we flip this flag to true. Okay. Now notice that, let's say you had content that was from pulpspy.com, but it wasn't overwritten. It came from pulpspy.com. That was the domain because that was the domain. It would have the flag set as false. And now you actually are different domains. You're different origins. So you wouldn't be able to see each other or be in the same tree. But we'll tackle that in a second. So that's what this is saying. Okay, so we'll give you a bunch of examples. Okay, so what here is or isn't the same domain? The same origin. So these two are the same origin, same protocol, same exact subdomain. Okay. The path doesn't matter. So the path is irrelevant. Okay. So you just ignore the path is everything after the slash. The third one is different because it's HTTP as opposed to HTTPS. This one's different because the subdomain is different. And then this one's also another example where the subdomain is different. It's technically a super domain of this, but they're considered different origins because they're not exactly the same subdomain. Okay, so the only two, of all the 5 things on the slide, the only 2 things that are the same origin are the first 2. Does that make sense? Okay. Now, let's say that we are getting, I'm downloading this HTML file. It's coming from users.encs.concordia.ca. But in this HTML file, I'm setting the document to be encs.concordia.ca. Okay? So now I end up, am I the same origin as this one? Okay, so the protocol is the same now. We both came over HTTPS. Because I overrid this domain, I'm allowed to do it because this is a super domain of users. Okay, so I went up the domain tree. So I am allowed to do this. This is valid. So protocol is the same. Domain is the same. We don't put the port number in. You can, but it's just sort of inferred that this is over port 443, so it's the same. The only difference here is the override flag is going to be different. Yeah.
Whenever you explicitly allow that, it works?
So as long as you, so there are document.domains that you're not allowed to set. So you can only set yourself, like, so if this file is coming from this domain, it can set document.domain to users.encs.concordia.ca. It can set it to encs.concordia.ca. It can set it to concordia.ca, and that's it. So there's three valid things that it could set it to.
Okay, even if I explicitly do it, there are only certain things that I can do, even if I edit it or something.
If you, I didn't quite get the question, but
Even if I explicitly change what you said,
yeah.
change, we cannot, it's very limited.
So it makes you broader, kind of. Like, so it broadens what you can see. Because now it's like any website or any resource that was loaded from any encs.concordia.ca, I can see. Or I'm in the same tree as. But yeah, it's limited. Like, there's not a lot of options that you can do.
Can you give another example?
Sure. So just let me finish this one, and then I'll. So I just wanted to point out that these are almost the same. So they have the same protocol, they have the same domain, they have the same port. But the first one, because it resulted from an override, the flag is set to true. And in the second one, because it was just naturally at encs.concordia, the flag was set to false. So again, they're actually in separate trees. Now, we probably don't want that, right? The whole point of overriding the domain was so that they could be put in the same tree. So how do we fix it? Well, what we can do is we can make the second domain do the same thing. So technically, you might say this doesn't mean anything, right? Like, this is already the domain, so why are you setting the domain to be exactly the same? The reason you're doing it is just to flip that flag to true, and now you'll match everyone else that flipped that flag because they were actually overriding the domain. Okay, so it's like a small, like, kind of technical point, but it's one. Yeah.
This is implemented in the browser?
Yep. So this is in the browser itself. So it's sort of how it assigns, how it splits the tree up into different subtrees. Yeah.
So browser set it automatically, or we have to, like, as a user or administrator, we have to set it?
So the resource itself can set it. So it has to be in this HTML file in order to override it. Yeah. So it's not an administrative thing. It's the, yeah.
Can I set multiple domains? Like,
I believe you can only set one. Yeah. You could load the resource more than once. So if you wanted to have it in all the different trees, you could load it like 3 times with different domains. But yeah. So you would have a copy, but it would be like 3 independent copies as opposed to the same.
but at a time one.
Yeah. But the point is it has to put it in a tree somewhere. So that's why you can't have multiple, because, yeah.
How does the site know that this flag has been triggered?
So the browser parses it, and then it sees it. So as a web designer, you don't know. I mean, you either put this in or not. But like the point is that, like, say I coded this page and you coded the other page, and we're trying to do something where we want to like pass data around and it's not working, then we don't know other than like troubleshooting in the browser. So we could see what the error message is, and it would say, oh, that's a different origin, so that's why it's not working. And then I would have to call you up and say, okay, you need to set this up, or you look on Stack Overflow or whatever. And then people are just like, always set document domain to concordia.ca, right? Like the most permissive, the widest thing. Just do it in every single website on your web page. Make sure you set it to the most permissive thing, and then everything's compatible with each other. But that's not what you want from a security perspective necessarily. Sometimes you do want to isolate resources.
So if we do an edit subdomain is different and the protocol is different, it still becomes it can still work.
If the protocol and the subdomain are the same, then yeah.
Change it if we change it.
Yeah, so if you override it, the only thing is that this flag flips from false to true. And then the other ones have to flip it as well.
Otherwise it will block out.
Otherwise, you'll be in different trees. So the thing here is just that you're now in different trees. So the JavaScript that's running, say that's assigned this origin, can't access stuff that was loaded over this origin. Okay. All right. Give me 2 minutes. I just have to update my parking on the street, and then so just you can chat amongst yourself for a minute or two. It'll just take me a second. Can I have this for a sec? I'll give it back. Okay, thanks. All right. Okay, is there other questions about this? Okay. All right, so you can set that aside for a second. Now I want to talk a bit about JavaScript, and we'll talk about the origins that are assigned. This will be a concrete example. Okay, so on the left, I'm on the website concordia.ca. You can see there's a lock, so it's loaded over HTTPS. Okay, and what I'm doing is I have some HTML, and one way to get JavaScript running is you can just literally put in the HTML. Okay, so you have a script tag, you open the script tag, you dump your source code in, and then you end the script tag. Okay, and then it will run when the website gets loaded. Okay, what origin do you think the browser would assign to this script element? So the script is technically a different resource. Even though it's buried in the HTML, it will pull it out and say, okay, this is the JavaScript resource. Yeah, I have to put an origin on it. So what origin am I going to put on it? Concordia.ca, right? Okay, so HTTPS Concordia.ca 443, no override. Okay, let's say that I, instead of putting the script in the HTML, the reason you don't do that is, like, say you want to change the JavaScript and you have like 10 websites and they all have the same script, then you have to go change all 10 of them, right? So it's better to just have your JavaScript in its own file, and then you just call the JavaScript file from your HTML. So you can do that again with the script tag, but in this case you say the source is here, it's this file, go download it and run it. And then if you want to change the JavaScript across your website, you just change to the one file. Okay, so this is going to be much more common. All right, so here we pull down this language.js file. It's coming from, the source of the file is https concordia.ca. The website that we're on is also https.concordia.ca. What origin is this going to get assigned to? Okay, so same thing, https concordia.ca. Okay, so these are the easy ones so far. Okay, now let's say that instead of the JavaScript being hosted on your own website, let's say that you're pulling a library in from somewhere else. Okay, so let's say you're pulling the library in from GitHub. All right, so exactly the same thing, except for now the JavaScript is on GitHub instead. What origin are we putting on this? Okay, so we have two, the way I see it, we have two options, right? We could put concordia.ca on it, or we could put GitHub on it, right? Those two seem to sort of make sense. So some people thought Concordia. Anyone think GitHub? Why would I give origin Concordia to something I got from GitHub?
Because it's embedded in the HTML file, so it's the same thing as if you've written it by hand in the HTML. No matter that you're pulling it from GitHub, it's running from Concordia. So.
Okay. So the answer is it's actually concordia.ca for that reason. Hopefully this is at least confusing though to you. If it's not confusing to you, it was confusing to decades of developers, okay, who did not understand this, and it led to something called cross-site scripting attacks, which we'll talk about in a second. Okay, so why is this not GitHub? Why are we assigning this origin Concordia? And the answer is that when I do this and I say, there's this lang.js file, what you should think of is the browser's going out, it's getting the code from that location, but it's almost like it's copy and pasting it into the website itself, okay? So the website itself is from concordia.ca. It's grabbing it, it's copy and pasting it and dumping it in it. And so it's actually not any different than this, okay? So in this, we said, this is origin concordia.ca because it's literally in line of the website. The only thing is there's this extra step of we have to get the file. It is coming from somewhere that's not us. But once we grab it, we're copy and pasting it into the website like this. And since it's in Concordia, then it's going to run with the permissions of concordia.ca. Okay? All right, so it's as if the script was copy and pasted into the website. Because it has the same origin as concordia.ca, it's in the same tree as concordia.ca, and it can do everything, like it can view all the resources that were loaded, it can overwrite them, it can change it, whatever. It's all powerful over concordia.ca. Okay. So it would never get blocked anyways, but it would get put in a different tree. Yeah. So let's use the word isolated.
So even a malicious code is put, something completely saying origin and a malicious code is due to this JavaScript, malicious code is and now it's compromised, right? The SOP is compromised in that case.
Okay, so let's say that lang.js is malicious. Yeah? Then, and I don't know, I get access to your GitHub credentials, and so I overwrite it. So what happens? Exactly what you said. If lang.js is malicious, it gets pulled in, it's assigned the origin concordia.ca, and it can overwrite the whole website. So what you're seeing is not necessarily what Concordia sent you at that point.
So if everything is compromised,
So everything is compromised, and the SOP just says that it took that malicious script and put it in the tree of concordia.ca. Yeah. So it doesn't break the policy or not. It just, that's what the policy says to do, and so that's what the browser does. But the problem with it is that developers don't understand that that's the policy necessarily. So when developers don't understand it, they might look at this and say, that's going to run with GitHub things, so I don't have to be that careful. The browser is going to use the SOP to isolate them. But the truth is, when you're pulling JavaScript in, it's as if you coded it yourself and it's running with the same context. Yeah, so it will, if the script is compromised, the website's compromised. Okay. So it can log input fields, it can phone home with the stuff that it's seeing. To some extent, it can try to read cookies. So it can do a lot of damage in this case. It can put up a password field, and as you type the letters in, it can read like screen read like what characters are being typed in. It can like phone to a server somewhere and tell them what characters are being typed in. Okay, so you don't want to get bad JavaScript running. Okay, now let's say that I have an ad library, or let's say I have a Facebook like button or something like that. What I tend to do is I tend to put it in an iframe. Okay, so now I have a website. The website is concordia.ca. It came over HTTPS. Inside this website, I have the HTML that defines an iframe. Okay, the iframe is set to facebook.com/ad.html. So the browser will now go, it will grab this ad.html file, okay? And it will, sorry, I don't know why it says closing script there. Just ignore that, that's a typo. It will grab this add.html file. It will start running that file, it will start going through it. And then let's say that this HTML file itself loads JavaScript, okay? So it loads, say, this get.js file from facebook.com as well, okay? So now we have JavaScript, it's running inside the iframe. iframe belongs to Facebook, and all of this is running on concordia.ca. For this JavaScript itself, what origin would it be? What do you think? So you have two options, basically. It's either going to be Facebook or it's going to be Concordia. So who thinks Concordia? Who thinks Facebook? Facebook. Okay, so the answer is Facebook, so you're right. So iframes are that thing that you use to isolate JavaScript. Okay, so they're kind of what people were looking for. So a lot of developers assume that this is isolated. It's not. If you want to isolate, you got to use an iframe, or there's a couple other mechanisms, but iframes are the most common. Okay. Yeah. Sorry, say it again. So the index.html, for example, of this would be assigned origin concordia.ca.
Yeah, I mean, where do you upload the file? Because, essentially, if you want to publish it, you need to have this. What I'm saying is that where do you upload it? Because if you are pulling just a file from GitHub, that's another question. So I want to, where is this concordia.ca? Where is it uploaded?
Okay, so there's no uploads per se. Like the browser, the very first thing the browser will get is the index.html of Concordia, and it will only load things because that file tells it to load something, or the thing that it loaded tells it to load something. So everything starts with that file, and all it has is links to the resources, and then it starts pulling stuff down. Yeah.
So I was asking, that is uploaded to like what's it called? Announcing site. That was I mean. That means the code is uploaded to, right?
Yeah. Yeah, so that would be the example of this. So GitHub is a hosting website for code. Yeah. And then whether you have write permissions over this would be up to GitHub. Like, do you have an account? Are you allowed to write to that code and things like that? Yeah. So we'll talk about that in a second. That's one way of attacking the system. Yeah. Okay. Now, just for fun, I don't think I have in the slide, but let's say that we're loading this over concordia.ca. The iframe is for facebook.com, and the script source is github.com. What origin is the script have now? So this is Concordia, pretend this says Facebook, and pretend this says GitHub. Okay, so it's going to be Facebook. Okay, so because the iframe is in Facebook, the iframe, once you have an iframe, it's almost like its own website. It's just like you went to that website itself. So everything that happens in that iframe. And the reason is the same as why this ends up with Concordia, because Concordia is the one that loads this JavaScript. Here, the Facebook iframe is loading this JavaScript. So everything it loads, unless if it creates another iframe within itself, everything it loads will be given the origin facebook.com.
What about CDNs?
CDNs, so they don't change anything unless if the domain changes. Yeah. So it's more of like an IP-based load balancing. So usually the domains are the same, and the browser is just looking at the domains itself, which is another point I didn't mention. But yeah, if you have resources and they're coming from different IP addresses, but they're all facebook.com in terms of domain, then they'll be considered same origin. Yeah.
The iframe is for which version of HTML? 6, 10, 12?
So it's in like which HTML file is it in, or like
Version of HTML, the iframe.
yeah.
You know, it's more like an attribute. Which of is it version 5, 6, 10, or maybe?
You mean like which version of HTML?
Yes, for the iframe.
It's always been there. Like so this stuff goes back to the 90s, like 96.
Yeah, but essentially it's frame. Or not iframe.
Okay, like are you saying like did iframes come into existence with HTML5?
I don't know. That's what
Yeah. So no, like they were always there. Yeah. Or maybe like there was some very, very early version of HTML. But like we've had iframes like since the 90s kind of thing. Yeah. Okay, and so what happens with an iframe is it sort of isolates. So all the stuff that Facebook's running in the iframe, it can't reach out of the iframe and affect Concordia. Similarly, Concordia can't reach into the iframe. So let's say there's a like button and Concordia would really like for you to click on it. It can't, even though it's loaded on the Concordia website, and even though it's running JavaScript, it can't reach into the iframe and click the button. JavaScript can do that. It could click something or do the equivalent of clicking it. But because the iframe isolates it, that's what stops it from reaching in. Okay? So iframes are a way of allowing resources to be isolated from each other. Now, let's say that Facebook and Concordia want to talk. They can do it. So there are ways to override the isolation. It won't be as simple as like you just get put in the same tree, but what you can do is you can pass messages back and forth. So with JavaScript, for example, there's window.postMessage. Both sites have to sort of authorize and say, I want to talk to this domain, and the iframe would have to say, I want to talk to the outside frame, and then they can talk. Okay. So there are ways, sometimes for functionality reasons, you do want to pass data back and forth. So there is mechanisms to override it, but they're still technically in different trees. They just have a protocol to talk with each other. Okay. So this leads to something we call cross-site scripting, which no doubt you've heard of. It's one of the most basic web attacks. And so it basically goes back to the question that we had earlier, which is, let's say I'm able to compromise lang.js. It gets loaded into concordia.ca. Then it's going to run with the permissions of concordia.ca, and it can completely overwrite the website. Okay, so what the user's looking at, again, I'm not hacking the server, so I'm not permanently changing that website on the server, but what I am doing is changing how you look at the website, what you look at when you visit that particular website. Other ways to get malicious JavaScript running would be if it's served over HTTP and you're a man in the middle, then you could just change the JavaScript itself or insert new files or whatever. And this is why now browsers will not allow this to happen. So it will block it. And we saw that earlier when we talked about HTTPS. Okay, another way you could do it is, let's say you have like a profile, a public profile like Twitter or X, I guess it's called now. And let's say I have a location, and so I'm going to type in location, and instead of typing in Montreal, I type in script, a bunch of code, and script tag. There is a chance that when you go there with your browser and your browser parses that website, it sees that script tag and says, that's not something I need to display to the user. That's a command to me. That's an HTML command, and so I'm going to start running whatever that script is. Okay, so it involves the fact that the website or your browser would have to confuse what should be data that's displayed to the user with actual code. Okay, but then in that case, it would start executing the code itself. Okay, so now we don't have this problem really anymore because most people aren't going to handcraft an HTML website from scratch. What people are going to do is they're going to use some frameworks or libraries or things like that, and these libraries know about this attack, and they'll sanitize all input. Okay, most things won't allow you to even put like a triangle bracket in. So if you want your username to have a triangle bracket, it probably won't even be allowed. That's one way of blocking it. Other things are just making sure that it's always interpreted as text. And yeah. Okay, and this is the original cross-site scripting attack. So what happened was actually very similar to this. In the days before Facebook, Twitter, Instagram, TikTok, there was something called MySpace. And someone did this. They put some script in their profile. And what it would do is when it ran is it would make you friend them. So you became their friend. And then it would change your profile so you had the same script now in your profile. So they tricked one person into looking at their profile screen. Now all of a sudden they were friends with them and they had the malicious code now on their profile. Then some other people looked at that person's profile. Same thing happened. Now they're infected. And it basically like ripped through the whole network in a day or whatever. And everyone was infected. And everyone was following this one person. And if I'm not mistaken, I think the person actually went to jail. They charged them for hacking then. And so, yeah, but anyways. And it caused like a bunch of like performance issues and things like that with the server because everyone was trying to like friend each other all the time. Okay, so yeah, so another user visits the site. They get confused by this. They start running the script and then it runs. So we call this persistent cross-site scripting because it's stored on the website. The web server is storing this information, so everyone who goes, it's not like some active attack where I'm in the middle or something like that. So it's persistent, and now it's not really a problem because all modern web frameworks, sanitize user input. Another kind of attack. Again, I want to say that I should have said this earlier. You're going to take a networking course, and they're going to show you all sorts of attacks like cross-site scripting. They'll show you like 100 variants of it. Mine is just, the reason I'm showing it is more to just show you how like the policy impacts it and that there's a wide variety of attacks. So this isn't meant to be like a comprehensive list. I'm just going to show you some of the common ones, and then I'll show you one weird one so you get a chance to understand how far an adversary will go to make one of these things work. But anyways, okay, so here's something. Let's say that let's say I give you this URL, say in an email or a text message, and you actually click on it, right? What would this URL do if you visited this, if you had to guess looking at it? Okay, so this is, first off, this is that RESTful like kind of architecture. Remember we talked about it last class. So yeah, so we have Google, it's a search. Q stands for query. And so basically this is the search term itself. Yeah. So if you click on that link, it's going to be as if you went to google.com and you typed this in as your search query. Okay. All right. Is there any chance that your browser might like parse this and think that this is a script that it should run as opposed to text to display if it's just sitting in a URL? So if it's just sitting in a URL, it's never going to confuse it because it's not expecting to see HTML there. Okay. The only way this would work is if somehow this query got copied into the HTML of the website. Okay. But that's exactly what would probably happen. Is you would load this URL and it would say, sorry, there's no results for. And then what Google will do is they'll copy and paste whatever the query is and they'll put it there in the HTML itself. Okay. So now this thing here would be sitting here. And if Google does a good job, then they'll display it correctly. And if it wasn't programmed very well, then your browser might confuse that for scripting that it needs to execute, and then it would actually execute it itself. And it wouldn't display anything, okay? So we call this, we can actually see what happens maybe. So you can see like if you literally do it with Google, they do put the search query in. Okay, so I clicked this link here, it's a little small here, but and they do exactly this, but they of course sanitize it, and so it's okay. So they display it. My browser doesn't confuse it for code. Okay, but there's lots of websites that aren't programmed, or at least previously weren't programmed in that way. They would just put it in sort of raw in the HTML. Then when your browser hit it, it would say, okay, that's a script I need to execute, and then it would execute it. Okay. Now, the nice thing about this is I didn't hack the website at all. Okay, there's nothing wrong with the website. I didn't get a malicious JavaScript running. I didn't do anything. All I did was give you a link. You click on a bad link, and then now you're subject to my cross-site scripting. Okay, so it's a very low entry attack. All I have to do is manipulate a URL, and I can get script running on the website that you're visiting. So we call it reflected cross-site scripting because you're reflecting from the URL the JavaScript into the website itself. Okay, and so reflective cross-site scripting was a big problem for a while. Then again, it kind of got fixed because web frameworks and stuff caught up, and they understood what this was. Okay, so now those are kind of the simple attacks, the basic attacks. Again, the emphasis here isn't on the attacks themselves. It's more just about the variety of them and why they arise because of the same origin policy. But now I'll show you the other extreme, which is one of the more elaborate attacks, just so that you get a sense that these attacks, they can be simple or they can be elaborate. Okay, let's say that you have kind of like a user profile, and you're able to edit information kind of like an administrative panel. And what would happen is if I typed in my email address and it was going to be displayed on my profile page, then websites would really prioritize making sure that there was no cross-site scripting that was allowed. There's no way to insert JavaScript into that field and have it displayed to another user. Okay? So all of the input fields, basically people would go through their website from top to finish, and they would say, okay, what's every single text input that a user could possibly put in a website? Which of them are displayed to all the users? And we're going to sanitize all of those. Okay? Now there's a second kind of text input that you can put into a website. It will store it, so it's persistent, but it only displays it back to you. It doesn't display it to all other users. So for example, you might have a website where it asks for your email address, but it tells you, don't worry, we're not going to display this to all the users. We're going to use it to authenticate you or whatever, but we're not going to display it. Okay? So in those input fields, it's not such a priority to make sure that they're not vulnerable to cross-site scripting because they'll never be displayed to another user anyways. So let's say that I could get some JavaScript and I could put it in one of those fields, save it, and then when I view my own profile, I would do a cross-site scripting attack on myself, right? So I'm attacking myself. You know, it's not good, but at the same time, it's not like I'm attacking everyone else that looks at my profile. Okay, so it was lower priority to. In fact, it was thought for a long time that it didn't matter. You could just don't worry about those input fields. They're not displayed publicly anyways, and so just whatever. Don't sanitize them at all. Okay, so what attackers said is, well, let's say that this is possible. Then here's an example of an attack that you could do where you could exploit this. And it's a blend of cross-site scripting and cross-site request forgery, which we saw last class. Okay, so here's how it works. What happens is the adversary will set up a bad website, call it evil.com, and they have to trick you into visiting the website. So this is the only way it works, okay? So you go and you visit that particular website. What they'll do is they'll first load an iframe, and there'll be a target. So let's say that, for example, I want to compromise your X account, and the vulnerability, this vulnerability exists in the X platform as well. Okay. All right. So what I'm going to do is I'm going to load an iframe, and I'm going to load your profile in this iframe. And if you're logged in to X, if Alice is logged into X in this case, then her profile will actually load in this iframe. Why does it load? Because her cookie's set. So she'll go to Twitter or X, sorry. She'll go to X and say, give me my profile. And by the way, here's my cookie. And X will be like, okay, I know who you are. So yeah, I'll load your profile itself. Okay, so her actual loaded profile is sitting in this iframe. Now, evil.com wants to know who her friends are or her private messages or whatever. I don't know what it wants to know. Okay, can it reach into this iframe and can it read, who her friends are and all this stuff that was just loaded from x.com? Okay, so it cannot because it's isolated. Okay, so this is what the iframe does. Because this iframe belongs to X, X can populate it with whatever it wants. Yes, it is running on evil.com, but evil.com can't reach in and actually read that information out. Okay, so this is perfectly safe. Alice, there's no danger to Alice at this point. Okay, even though there's this cross-site request forgery, if you will, happening, it's so far so good. Okay, so the adversary can't reach in, it's isolated, and this is the same origin policy that creates that isolation, and it also makes it safe to have like the functionality of things like this. Now, let's say that because X or Twitter in this case, it uses, these are sort of made up URLs, but let's say it uses the RESTful architecture. What it could do next is it could load another iframe, and it could say, okay, I want you to load twitter.com sign out equals true. And we'll pretend that whenever that URL is invoked, Twitter says, okay, this user wants to sign out. Okay. So now what it will do is it will load this iframe and Alice will be signed out of this iframe. Okay. Now, because this iframe was already loaded, what happens to it? Okay. It just sits there. Okay, if you refresh this, or if it was set to auto refresh or things like that, as soon as that refresh happened, then this would get logged out too. But as long as there's no refresh, then it's still just sitting there. It loaded, it's sitting there waiting for whatever. Okay, so in this iframe, the adversary logs the user out. Then what they can do is load a third iframe, and in this case, they can load themselves in. Okay, they can log themselves in. Sorry. All right, so now they're logged in. Again, we'll assume that you can somehow do that over just URL manipulation. And so now they're logged into this iframe. And we're going to assume that they have one of those scripts that's stored in some profile information that only they can see. Okay, but because this iframe is loaded and it's loaded with them logged in, then that script runs in this iframe. Okay. All right, so basically the adversary kind of logs themselves in. They go look at that part of the profile that has the bad script embedded in it. Now that script is running. Okay, now let's say the script is running in the third iframe. Yeah, what can it do? Can it impact everything that's outside of the iframe? Evil.com? No, it's isolated, right? Could the third iframe reach into the second or the first iframe? Who thinks yes? Who thinks no?
Yes.
Let's say there's no refresh. And why not? Okay, how do we isolate things? What's the policy called? The same origin policy. Okay, so we put things from the same origin in the same tree. All right, if they're in the same tree, they're not isolated. If they're in different trees, they're isolated. What tree is this iframe going into? Okay, it's going in the Twitter tree. What tree are these other two iframes in? They're also in Twitter, right? Are they from the same origin? Yeah, okay, so they're all going to be part of the same origin. They're all going to be put in the same tree, and they can all talk to each other. Okay, so even though they're three separate iframes, because they're all the same, they all have the same origin, the browser is going to put them all together. Okay, all right, so final question, can this script that's running in the third iframe reach into the first iframe, read everything that's sitting there, phone it home to a server or something like that? It can. Okay, because it's not isolated, because they're from the same origin, they're all on the same website, they're from the same origin. Okay. All right, so the script in the third iframe can read the data in the first iframe, and it could phone it home to the adversary itself. Okay, yeah. So then you have three origins. So evil.com would have its own origin. The two Twitter frames could talk to each other. They would have the same origin, and then Facebook would have its own origin, which would just consist of the first iframe. So if you, for example, let's say that this script attack that you did, you could do it on Facebook, but you wanted to read someone's Twitter account, you can't do that. So it necessarily has to be the platform that you're attacking and the platform that you're trying to siphon data from has to be the same. Okay.
The user still doesn't have any idea about username and password, right? Because that frame is isolated.
Correct. Yeah. So this couldn't reach in and steal the username password from this. And they're already logged out anyway, so it might be able to try and read the cookie or something like that. But because you had to log them out in order to make the attack work, the cookie's gone anyway, so it's not of use to you. So so it's limited in terms of what it can do, but it could read everything that it loaded. And you could imagine loading 1,000 iframes, one for like say it's in your inbox, and page 1, page 2, page 3. You could load lots and lots of stuff, then do the attack, and then read all of it. But it's basically like just scraping stuff off of your profile and sending it home. Yeah. Okay, we call it self-inflicted because in the original part of the attack, we're basically infecting ourselves. Okay, but because I can get you logged into my account and looking at my account, it's no longer self-inflicted. Infected. If I infect myself, because now I log you into my account and you're looking at my account, now you're infected as well. Okay. So anyway, so this is like the most complicated thing you'll see, but you can see that this is the level that the adversary thinks at. They don't just do simple let's drop script tags into Twitter bio profiles and get people to click on it. They're doing very complicated thing. And this is nice because it kind of blends. You have a cross-site request. You have RESTful architectures and manipulating URLs and getting actions to be taken because of URLs. And then you also have the self-inflicted XSS all put together. Okay. Now, while we're on the topic, what if let's rewind to the second iframe. So here I ask for it to be signed out. Okay. Who am I signing out? Who's logged in? Whose account is doing this sign out action? So it will be Alice's account itself. Okay. Why does Twitter think that Alice is the one that's asking to sign out? Not a trick question. Why? What is the mechanism? It's the cookie, okay? So the cookie came from Alice's account. Twitter says, I know who you are. You're Alice. I'm going to sign you out, okay? What if we did that trick that we did last class to prevent cross-site request forgeries, where we say, Twitter's only going to honor any URL if it has the cookie in the URL itself? Would it be possible to log the user out in step 2? So the answer is no, okay? And in fact, even in step 1, when you tried to grab this, that wouldn't go through either because the cookie wouldn't be in the URL itself. Okay. So if you shut down cross-site request forgery attacks, you could also prevent this attack from happening as well. So that's another path forward. So this relies on both cross-site request forgeries and cross-site scripting. Okay, any questions about this? This is the most complicated attack you probably have seen in the whole class. Maybe the cookie or compression one is comparable, but. Okay, good. All right, I'll show a couple more. This lecture will be a little shorter than the rest, by the way. So it's I think we're almost at the end. So I won't do a break. We'll just end earlier. Okay, so here's another one. Let's say that I go to evil.com. All right, sorry, I lure you to evil.com. So Alice is now on my website. I load a Facebook like button. I do it with an iframe. Iframes for Facebook. Can I reach in from evil.com and press that like button? Okay, so I have this iframe. It's loaded on my website, evil.com, and I really want you to like my article. And so can I reach into the iframe, click that like button, and then have it, and then because Facebook knows who the user is, we're assuming that Alice is actually logged in to Facebook. This is actually Alice's real friends and her real profile and all that stuff. So if that like button gets pressed, it does get reflected on Alice's actual profile. So what can I reach in or not? Okay, I can't reach in. Why can't I? Because it's an iframe, okay? So the iframe, again, it isolates things, okay? So this is why you can have a Facebook like button. If we didn't have iframes in isolation, you couldn't do it because the websites that loaded it would just press the button automatically, okay? So I can't reach in, I can't actually click the like button. Let's say that I had the same origin as let's say I had the same origin as inside, or I got some JavaScript running in the iframe. Could I do the equivalent of clicking the like button through JavaScript? Like I can't move the user's mouse and make a click, right? But the HTML would be set up that when you click that button, all it does is it sends a URL that says the user clicked it in the URL. I could send that URL from JavaScript myself. Okay, so I can click the button. If I can get JavaScript running in there, I can do the equivalent of clicking the button, even if it doesn't look like the user like actually clicking it. Does that make sense? Okay, so it's important that this isolation exists. All right. Yeah.
The first question, I mean, apparently, this phone you explain is because there's a script running, which is JavaScript that's carrying the code. Now, you know, for JavaScript, you can do two actions. Either you do mouse over or you click. Now, for the first question, it was mouse over. The second one was a click. Now, if you do mouse over, apparently, the origin, you still have an origin because she's still connected to Facebook on another browser, which origin and they are the same source because there's a traffic going on. Now, if you do a mouse over on the iPhone, is it not supposed to still reflect on Alice's Facebook account?
So I didn't quite catch the middle part, but you're loading resources from multiple websites.
Yes, but the iframe, I mean, since it's an HTML library, or even if at that, if you do mouse over, I mean, it's not supposed to because the origin sees there's a connection on the browser itself that Alice's file is, I mean, she can because she's connected to Facebook.
Okay, just are you worried about like tracking where the mouse goes, or you want to get the user to move their mouse? Like, are you trying to write to the mouse, or are you trying to just read where the mouse is?
When you move over, different.
Yeah, so the user moves they hover, let's say they're hovering over the Facebook like thing. Are you saying, can the JavaScript outside know the coordinates of where the mouse is? Yes, yeah, I think so, yeah. Yeah, I think you can always query like sort of where the coordinates of the mouse is. Yeah. You also have control over the iframe itself. You can put it anywhere you want. You can make it any size. You can make it 1 pixel by 1 pixel. You can have it move around. So yeah, you could definitely figure out where the mouse is going, even if it somehow, like when I cross the threshold, it stops. But I believe, like, I'm not an expert in this like user interface stuff, but I think you can always coordinate where the mouse is. You can always get its coordinates. Yeah, but you can't make it click. That's the point. You can read where you can't write. You can't say move the mouse here. You can just read where it is, and you can't say click. Yeah. Okay. All right. Is there any other way we could get this thing to click? Okay. So clickjacking, the attack here, it's kind of a dumb attack in a sense, but it was very, very effective. So first off, the adversary can't reach in and just click the like button because of the isolation. But what they could do is they could take some image, and what they could do is they could move it over the like button. They control the iframe itself. Okay, so they control the layout of the website. Are you allowed to stack things on top of each other? So you could say yes or no, but browsers let you do it. Okay, so you can have an iframe that Facebook is populating, and you can overlay stuff on top of it that you control. So this claim prize image, what origin is it? It's evil.com's origin. It looks like it's in the iframe, but it's not. It's not actually. It's more like over the iframe as opposed to in the iframe itself. Okay. And even when we talk about in the iframe, that's kind of a metaphor, right? For it doesn't. It has nothing to do with the layout of the website. It's just stuff that was loaded by the iframe itself. Okay. So that's fine. So we put this image over top. All right. Now I want to claim the prize, so I'm going to click claim prize. What happens? Okay, so we think it clicks the button underneath, otherwise I wouldn't be showing it. But are you sure about that? Because now I have an image. Maybe I just click on the, like say I clicked on this and dragged it, it would kind of drag the image, right? It's not going to drag the Facebook like. So isn't it like if you click on an image, period, like say there's nothing underneath it, you just click on an image, what happens? Nothing, right? Yeah, and so if I put an image on top and you click on it, why is that not like clicking on an image? Okay. So it is actually, so far it is actually, if this attack doesn't quite work, because when I go to click on it, it's just like clicking on the image itself. Okay. Now, sometimes for graphical reasons, you do want to overlay things on top of each other. And one thing that JavaScript allows you to do is it says you can sort of tell, if I'm confused about whether what a click should do, why don't you just tell me what it should do? Okay, so they had this option called transparent click. So what you could do is you could create an image and you could set its attribute to be transparent click, and then if someone clicked on it, it just ignores it. It puts it through to whatever's below it. Okay, so what you would need to do is, you would put some image here, and then you would set the parameters of the image, which evil.com can do because the image itself belongs to evil.com. It can set transparent click. Then when the user clicks on it, the click goes through it, and then it actually clicks the button below. Okay? And so, again, there was a period of time where these kinds of attacks were popular. People would log into their Facebook, and there would be a bunch of ads, and they'd be like, I was hacked, right? Because there's all these ads, I didn't post them. But in reality, they weren't hacked per se. It wasn't like someone guessed their password or compromised their account. It's just they went to some shady website and it was doing this clickjacking, and they clicked on something. And as a result, it would be like it might pop up an error message, and then to close it, the button would be underneath it. It wouldn't be like a real error message or things like that. People were clicking on things, and then it was doing actions on their account with Facebook. But again, their account wasn't compromised. Once they got off the bad website, then no one had access to their Facebook anymore. But then Facebook, you can do things to sort of lock down. You can say, first off, transparent click has almost no legitimate purpose, right? The dangers of it now far outweigh the benefits. And so I think that browsers more or less block it. You can definitely get extensions that will just turn transparent click off, or if it ever sees something with transparent click, it might not let you go to the website or things like that. You don't really break the web if you just turn transparent click off. It almost exclusively was used for this attack. But anyways, it was something that was possible with the right combinations of web stuff. Okay. And so if you, again, there is a cross-site request here happening that makes the attack work. If you weren't logged into Facebook and you went to this website, the iframe would load, but when you click, there wouldn't be a like button there. Or if there was a like button when you clicked on it, then it would say, okay, can you log in or something like that. But yeah. Okay, so what are some lessons from this browser policy stuff? First, it's hard to get the policies right. So policies are hard, period. Okay, whether it's browsers, whether it's airports, whether it's SIM swapping or whatever, it's difficult to get them right. Another thing is these policies were made in the 90s. So I had that in the last lecture. I didn't mention it today, but the same origin policy came in 95. Cookie policy came in 94. And so these are this is really before people were using JavaScript, right? If the web wasn't like it is now. If someone had JavaScript, it was more like a toy. They gave you a calculator so you could type in 4 + 4 and it would say 8 or whatever. It was not the modern web. And you barely weaved resources together from different websites, right? But anyways, back in that ancient web, that's where the cookie policy came from. That's where the same origin policy came from. The big problem with the same origin policy is it's not a right policy or a wrong policy. Okay, there's nothing right or wrong about it. It's not a good policy or a bad policy. The thing about it that led to a lot of attacks is that just the developers didn't understand it. Okay, they didn't have the right mental model of what it is. They thought that if you load a script from GitHub.com, that it wouldn't run with the permissions of the website that was running it, and that's where a lot of the problems came from. Once we got developers to understand, or at least use libraries that were designed by people that understood the problems, a lot of these problems go away. Policies are tough because there's no good methodology. We talked about this before, but if it's software, for example, you can do static analysis, dynamic analysis, that kind of stuff. So we have like really good tools. If it's some sort of like cryptographic protocol, there is a way to sort of do it in an automated way that kind of works. But we have math-based approaches. We can write out a mathematical proof. We can try and reduce it to a hard problem or that type of thing. We don't really have that level of maturity for policies yet. Okay. The best that we can do is we can take the policy, we can turn it into code, or like a set of logic, like expressing code, a set of logic constraints. Then we can ask a computer, can you figure out a way to, we think that this property should always be true. Can you figure out a way where it might not be true? So someone did that exercise with the same origin policy. They coded it all up in a language called Alloy, and they found all sorts of weird things because the same origin policy is really complicated as implemented by browsers. And they found all these weird corner cases where you could trigger things that you weren't allowed to trigger. And then they took those findings back to Firefox, and I'm sure all the browsers changed how things were done at a subtle level. But anyways. If you get it wrong in the first place, it's also hard to kind of undo it because all these websites are now programmed the way that you set the policy. And so if you change the policy, then you might break all the old websites. Okay. You can add policies or new languages and things like that. So there are some new security policies and stuff that have been added. So you can do a kind of additive thing, but it's hard to do a subtractive thing where you remove policies. Sometimes we do it anyways. So for example, browsers eventually got to the point where they said, we cannot load JavaScript over HTTP. We're going to turn that off, and it's going to break some websites, and that's fine. The breakage is, we're going to warn people. We're not doing it for 2 years. We're going to warn them. Maybe in the intern we'll show a scary warning or message or a weird icon or something like that. But eventually we're just going to pull the plug on it, and then they're not going to load. And so yeah, sometimes if the issues get severe enough, you do have to break websites. But in general, you don't want to do it. And so this also makes policies difficult. The other thing that we see is developers, they just want the website to work, right? They want to share cookies. They want their JavaScript to talk to each other and things like that. And so they'll just do the most permissive thing. Lots of help websites are full of not helpful security advice of just make everything as permissive as possible so that it can talk together. And so that's also a problem. And it goes kind of back, I guess, to the second thing, which is the website's not working because they don't have the right mental model of what the policy is. And so instead of learning the right mental model, they're taking a shortcut, which is just, make it permissive. And then you can add customization and overrides and things like that. You're adding complexity to the policy. The more complicated a policy gets, generally, the more chance there's some sort of loophole to it. So you don't want to always just start with a basic policy and then be well, in this case, you could do that. In this case, you could do that, and add a whole bunch of exemptions. Then it gets even harder to understand, and there's a greater chance that there might be problems with it. Okay, so first off, questions about today's lecture? Yeah. Yeah, so sandboxing can mean different things. So it already, when I say it isolates, you could call that a sandbox, if you will. So an iframe is a sandbox.
Yeah, but what if I put a malicious code in iframe?
Yeah.
And that affects the remaining websites?
Okay, let's just break it down step by step. So if I get a malicious script running inside the iframe, that only impacts the iframe itself. Yeah, so it won't break. I can't break out of the iframe itself. Or if this picture were reversed and it were Facebook.com and Facebook outsourced its ads to me and I was malicious, so I could get my malicious JavaScript running on your Facebook, but it was in an iframe, I can't do anything with your Facebook itself. Yeah, so the iframe is a kind of sandbox. It's an isolation. Sandbox is usually used for, it means the same thing, but it's more like you might sandbox your browser so that if something breaks out of your browser, it doesn't overwrite your system settings or things like that type of thing. Yeah. But again, the high level concept of isolation is the same. Yep.
I mean, I know essentially this kind of attacks happens more in the 90s. Right now, it's more content, but why do we have this sort? Because, sometimes, like you rightly said, when you open Facebook account, there are a lot of ads. Or I know a lot of people want to publish their products, boost out a lot of stuff. But why do Facebook, if they know that most of these iframes works or adverts are malicious, why do they allow it in most cases?
Oh, yeah, yes. Okay, so first off, I can't answer it for sure because I don't work there, but I suspect that it was good for business anyway, and the amount of legitimate uses overwhelmed it. But the second thing is, let's say, put yourself in Facebook's shoes. You know this is happening. Is there anything you can do? You can't control evil.com. You can't change web browsers. You can't get rid of transparent click. What could you do yourself that's fully in your control? This only works because there's a cross-site request.
Exactly. So
Yeah.
I can block it because apparently they are running on my domain. They are connecting from my server to the user, so I can block malicious domain.
Yeah.
Facebook can do that, right?
Yeah, so in this case, you can't, the Facebook actually doesn't know that they're running on evil.com. What they see is Alice comes to them and asks for something. Alice is asking because evil.com told them to. Maybe it gets thrown in a refer header or something like that. But in general, I wouldn't rely on the fact that I would know that it wasn't Alice that typed facebook.com and press enter as opposed to evil.com loading it in it. So you couldn't block it. But what you could do is if you can stop the cross-site request forgery, then you can stop this attack. Yeah? And so how do you stop the... Actually, that's not even true. You can't actually stop this attack because Facebook is going to load this with cross-site request forgery protection. Yeah. So this attack was So that actually is why this attack took a while to fix. Is Facebook actually can't do anything to fix it. So the other kinds of attacks like the cross-site scripting, this kind of thing, they can put on that cross-site request forgery protection. And then these kind of attacks go away. But clickjacking, they couldn't get rid of because they could stop allowing people to embed Facebook stuff. But short of that, they couldn't actually do anything to stop it. Yeah. Because you're literally getting the user to do what they were designed to do, which is click on it. Yeah. Yeah.
I have a website and iframes and things like that, and I'm using extensions. The extension can see the iframe, right? And also the iframe can see the extension. So could I hit an extension with something malicious in an iframe?
Okay. So.
Theoretically, I could, right?
Yeah, okay. So I actually don't know that I can answer this question. I don't know enough about how extensions work. I do know they're allowed to inject JavaScript, but I don't know what origin it's assigned, if they're allowed to choose or not. And that would be...
Yeah, this would be my question because many extensions run with elevated privileges to do their thing.
Yeah, exactly.
That could be,
Yeah, so like, for example, earlier when I loaded TSN and we looked at it, you can actually see the very first JavaScript here is from this Zotero connector. That is like an extension that I have installed up here. So it's injecting that JavaScript into the website, but I don't know if it's, first off, I would assume that it's given origin tsn.ca. Yeah, But then if there's an iframe, it would be isolated from it. I don't know if it can say, actually, I want to go in that iframe, so give me that origin, or not, or if it just by default. I don't know if it's like a limitation in the functionality or if it's a security thing or something like that. But in general, extensions at the very least can run with the permissions of the website that's being loaded. So you can do a lot of damage in the one direction of a malicious extension. You know, if you get a malicious extension, you basically, it controls what iframes are loaded ultimately anyways. So a malicious extension like can ruin your web experience on every website. But I don't know if the vice versa is possible. If you get malicious website running, it can see the content of this JavaScript itself. But because the JavaScript is running with TSN, it's not like you can break into the Zotero account and see stuff anyway. So I don't know that you can do much damage in the reverse direction. But yeah. But extensions do inject JavaScript basically on every website by default.
Even if the iframe is posted on the same parent of origin, even then whatever malicious code I put in iframe cannot access the parent directly. That's what my question is.
Yep.
Can it be access the cookies, can it still read the script and everything, whatever is there in the iframe?
Correct.
Post the iframe directly on the parent origin, inside the parent origin. So that is like, it's a direct attack.
Let me just try. I thought I had a picture of it, but I guess it's said in words here. But yeah, it's sort of like this. So if I get my malicious script in the iframe, I can't reach out of the iframe into the parent page. If I get my malicious script running in the parent, I can't reach into the iframe. But I also control whether that iframe loads or not, because the iframe's only being loaded because the parent page is telling my browser to load it. So I can control the iframe itself. But once it's loaded and I let someone else populate it, I can't see what they did inside the iframe itself.
So even if I post it on the parent origin, I cannot access the iframe cannot access the parent directly, or
Yeah.
is that what?
Yes, correct. Yeah, so I can't reach, malicious JavaScript in the iframe can't reach outside, and malicious JavaScript outside can't reach inside. So they're isolated from each other. Is your question different than that, or?
It is the same, but then I have read that I have read that iframe will completely have is isolated from the parent page somewhere, so that I had that in mind. So
No.
that's why I asked
Yeah.
sandboxing them, but I didn't know that it was.
Yeah, so they're both isolated from each other. They're both in different trees, and so you can only see the stuff that's in your own branch of the tree. Okay, other questions? Okay, so just a reminder, if you weren't here at the start of class, next class will be virtual, so there's a pre-recorded. The class after, it covers the last two lectures. The last two lectures are on social engineering. There's a pre-recorded video that covers all of social engineering. It's a little longer than one class. It's a little shorter than two classes. Try to watch it next week, though, even though it's a little bit longer. And then the week after, the reason I'm doing it virtually is because I'll be traveling the week after. I will, though, have a Zoom call, and so you can ask me questions about whatever, about the exam or whatever you want to ask about, and or about the social engineering lecture itself. Probably won't start when we normally start at 5:45. We'll start a little later. I have to look at the schedule, but I'm speaking at the end of the day. So I'll send an email tomorrow reminding you not to come to class. Sorry, I'll send an email next week reminding you not to come to class, and then I'll try and send you an email the following week reminding you about the class. But I'll put it all on Moodle. The link will be on Moodle and things like that. Projects, there's an extension so you can go to, I think it's the 22nd of April. I'll update Moodle with that. And I talked a bit about the exam. You can just listen to the recording at the start, and you can ask me questions about that next time. Okay, any other things?
Thank you, Professor.
Yeah. No worries. Nothing? Okay, good. So I'll see you virtually in 2 weeks, and then that will be the last class. So this will be the last in-person class, but there's still class left. So just because it's online, don't think it's not going to be on the exam or something like that. So it's yeah. But anyways, okay, bye.